Hi, today we are going to discuss about waveguides. Concept of waveguide: a hollow metallic tube of uniform cross-section for transmitting electromagnetic waves by successive reflections from the inner walls of the tube is called waveguide. So there are two types: rectangular waveguide and circular waveguide, and one more is parallel plate waveguides. So here we are going to discuss about rectangular waveguide and circular waveguides. Waveguides may be used to carry energy between pieces of equipment. Waveguides are made from copper and aluminum. These metals are extruded into long rectangular or circular pipes. Types of waveguide: rectangular waveguide, circular waveguide. Rectangular waveguide, the dominant mode is TE10. So the dominant mode is the mode which is having lowest cutoff frequency, that is called dominant mode. Supports TE and TM waves but not TEM waves. There is only one conductor. Bands between 1 GHz to above 220 GHz. This is the shape of the rectangular waveguide. And field configuration for TE mode and TM mode in the rectangular waveguide. Circular waveguide, the dominant mode is TE11, the highest possible bandwidth, allowing only a single mode to propagate. This is the wave in circular waveguide. Next, TE mode, that is transverse electric mode. Electric field perpendicular to direction of propagation. Magnetic components are in the direction of propagation. TE modes have no electric field in direction of propagation. TE mode is subdivided into TE10, TE11, TE20, TE01. The dominant mode is TE10. Transverse magnetic mode. Magnetic field is perpendicular to the direction of propagation. Electric components are in the direction of propagation. TE modes have no magnetic field in the direction of propagation. TM modes is subdivided into TM11, TM21. The dominant mode is TM01. TEM mode. In TEM mode, both the electric field and magnetic field are entirely transverse to the direction of wave propagation. There is no longitudinal components of either field, that is E is equal to 0, H is equal to 0. Key characteristics of TEM mode: both E and H fields are perpendicular to the direction of propagation. No cutoff frequency, that is, can propagate from DC to very high frequencies. Simplest mode of propagation. Power flows purely due to the transverse field. Field pattern does not change with the frequency. TM mode. Why TM mode exists? TM mode requires two conductors, hence it occurs on coaxial cable, parallel plate transmission line, two-wire transmission line. TM mode does not exist in waveguides because waveguides only one conductor it has, so it does not exist on TM mode. Why TM mode has no cutoff frequency? Cutoff frequency arises due to boundary conditions requiring for longitudinal fields. TM mode has no longitudinal fields, so the cutoff frequency equal to 0, Fc equal to 0. Advantages of TM mode: suppose DC and low frequency signals, simple mathematical analysis, no dispersion in ideal lines, uniform field distribution. Next, comparison between TE, TM and TEM modes. Electric field in the direction of propagation: for TE mode, E is equal to 0. TM mode non-zero, that is E is not equal to 0. For TEM mode 0. Magnetic field: for TE mode non-zero. For TM mode it is equal to 0. For TEM mode 0. Nature of the field: E field is purely traversive, there is electric field. H field is purely traversive. Both E and H are purely traversive. Longitudinal components: only magnetic field exists, only electric field exists, no longitudinal components. Cutoff frequency exists in TM mode and TE mode, and there is no cutoff frequency in TEM mode. Dominant mode: TE10 mode in rectangular waveguide. TM01 mode, higher cutoff than TE10. Only TEM mode. Power flow via transverse plus longitudinal fields, and here also same, and here via transverse field only, there is in TEM mode. Mathematical complexity: in TE mode moderate and TM mode higher than TE, and TEM mode it is simplest, where each mode occurs in TE mode, TE, TM and TEM. So in TE mode, rectangular waveguide, circular waveguide, dominant mode is TE10. In TM mode, rectangular waveguide, circular waveguides used at high frequencies than transverse electric modes. TEM mode, coaxial cables, two wire lines, parallel plate lines. Application of waveguides to reduce attenuation loss can operate only above certain frequencies. Short and medium distance broadband communication. Cavity resonator and applications. An electronic device consisting of space usually enclosed by metallic balls within which resonant electromagnetic fields may be excited and extracted for use in microwave system. So this is the rectangular waveguides within coupling hole, sample thickness. Types of cavity resonator: regulated cavity resonator, unregulated cavity resonator, coaxial cavity resonator, capacitive cavity resonator, inductive cavity resonator, waveguide cavity resonator, reentrant cavity resonator. Applications of cavity resonator: waveguides are used at the high frequencies to transmit power and signals. Similarly, cavity resonators are employed as tuned circuits at such frequencies. Cavity resonators are widely used as the frequency determining element in the microwave oscillators. Thank you.